Welcome back. We are going to cover TensorFlow fundamentals right now. Alright, so a lot of tutorials take this format where, like, how to draw an owl image. Step 1, draw 2 circles. Step 2, draw the rest of the owl. So a lot of deep learning tutorials go calculate this derivative, implement backpropagation, now do AI. We're going to add at least a couple more steps in between, and we're going to use TensorFlow to do it. So what is TensorFlow? TensorFlow is Google's open source library for data flow computations. The name comes from two things. First is the tensor. A tensor is an n-dimensional array. And second is the flow, which refers to the DAG computations. TensorFlow is interesting because it uses directed acyclic graphs, DAGs, to model data in the form of tensors as they flow through operation nodes. This is really optimized for distributed ML tasks, like multiplying many matrices across many GPUs. It's not the only option. There are many other popular deep learning libraries, which include Caffe2, Theano, Torch, and Keras. So as of January 2017, Keras is officially supported by TensorFlow and is a high-level library that sits on top of TensorFlow and calls TensorFlow. So day to day, we really like using Keras to implement things, but for the purposes of this demonstration, we're going to stick to the lower level, slightly lower level TensorFlow library. So even within the TensorFlow library, there's many levels depending on how hands-on you want to get with your code. This kind of chart shows you that you can program TensorFlow models in core Python. You can hook it up to CPUs, GPUs, or TPUs with just a couple of lines of code. Or you can use the tf-contrib-learn library. So most people will be operating here using the predefined models. So you can actually train a deep neural network without having to define every single node and every single interaction. You can just call DNN regressor, DNN classifier from this level of the library, tf-contrib-learn. Or one level higher, you can use Keras to call in a lot of these models. So day to day, unless you're doing very specific machine learning research, unless you're like a computer science PhD student, you will mostly be operating on this layer or this layer and using predefined metric functions, loss functions, optimization functions, and activation functions. So the whole point of going through the pieces of an activation function earlier in this course, now you might be asking yourself, well, shoot, I could have just copy-pasted a line in. Why did I have to learn that? You learn that so you have a better intuition of what happens here, but you don't actually need to know how every single activation function works in order to be able to use it. You can just call it via this library. The TensorFlow core, how does it work? There's two components to it. First, you build a computational graph, and then you flow the data through the computational graph. Now the tensors represent the data, and you build the computational graph node by node, where a node takes in 0 or more tensors and produces another tensor. A node can be a constant, so a node can just always produce a tensor with value 5, and that's like a constant node. A variable, it just operates like a variable, or an operation, where you take a tensor, you take two tensors, run it through a summation node, and the tensor output is the sum of those two tensors. Those are the three core node types. So here's an example of a compute graph. Take a look at this. Pause this video here for a few minutes. See if you can tell what kind of computations are being run just by eyeballing this. Okay. What's happening here is this is actually the linear model we've been working with this whole time. W multiplied by X added to B, and then calculating the loss functions, calculating the gradients, training it back and forth. This is the static graph. This is how you define the learning operation here. So we're now going to switch to Data Lab for some coding on the TensorFlow core exercise model. We're going to implement this computational graph on the right in NumPy once, and then again in TensorFlow Core just to demonstrate the difference. At this level, this is just, taking x times y, which will output a tensor A, adding this tensor A to this tensor Z, and taking this tensor B and summing it all over itself to get tensor C. So, alright, go forth.